volume is accounted for in international construction. Now what we mean by international construction is construction done by one country in another country. So if you combine all of that, it's about 12 to 15%. Now, do you think that amount is increasing in terms of percentage or decreasing? What do you think? Anybody? Increasing. And it is increasing in this way. I teach a course in my graduate program, Topics in International Construction. And I have been observing the trend of the volume, and this is what I've seen. And of course, I think you will know why there is a flat portion from 2008 to 2010, right? There has been a global recession. But still, it didn't go down. You see that it didn't go down. In terms of, these dollar figures are not inflation adjusted, which means this is the actual volume of dollars that have been spent. And it didn't go down during the recession period. And now it's going up again. And the latest figure in 2012 is about $500 billion, US $500 billion. Now, why is this happening? As I asked the question whether it's increasing or decreasing, I think you agree with me that it is increasing. One of the reasons it is increasing is the push for project scale. The volume and the size of some infrastructure projects are becoming very, very large. And there have been economies other than developing countries like G7 or G8. There are other economies that are growing. For example, BRIC, and their GNP is increasing, so there are bigger and bigger infrastructure projects coming along. At the same time, there have been breakthroughs in technology. We don't see most of that, but the technology that has been increasingly that we have been observing is in the information and communication technology, which has nothing to do with construction, but it is helping construction. It is helping to undertake bigger and larger construction. I'll give you a few examples, and these examples are featured in Engineering News Record. And this one is in Saudi Arabia, $20 billion project. So think about the volume in terms of just money. $20 billion projects. There are many third world countries, their annual budget is not $20 billion. But this is one single project. There's another one in Australia, which is a $15 billion project. It's a liquefied natural gas facility. And there's one in Mongolia, $6 billion project. Of course, I also have to tell you that most of these projects are international projects, meaning contractors of one country doing construction in another country. Those are international projects. This one is in Australia, $37 billion project. This is Panama Canal expansion that started in 2006 and is finishing either this year or next year. It's a $6 billion project. So what role is technology playing in this? There are several kinds of technology or technological innovation that we are witnessing. Of course, I mentioned one is computing, information and communication technology, and automation. There are two different kinds of applications of computing technology. One is information, in the field of information and communication. Another is automation. Maybe you can say robotics. These are the two different types of computing technology that we are seeing. And then, of course, we are also seeing push for innovative construction materials. Now, the first two, computing and innovative materials, I want to emphasize these two words. One is process innovation, another is product innovation. I'll come back to this differentiation between process and product in construction. It's a very important differentiation. And then we're also seeing technological breakthroughs in high-rise buildings and infrastructure construction. Some of the examples you have already seen when I talked about those giga projects. They're not called mega projects anymore, they are called giga projects. They're so big. Now, a little more contextual information. Between 2001 and 2012, the volume of international construction increased 5 times. This was the question I asked before. Is the percentage of international construction increasing or not? It is increasing, and it is increased. It has increased over the last 10 years about 5 times, from 100 billion to 500 billion. What is the implication? The implication is that even if it is not directly, indirectly you can say that in a large-scale construction project, there will be more information exchanged and processed. Naturally, right? In a construction project, you will have to know how to generate, store, and exchange information among the participants in the project. It's very important, and that's why we are seeing breakthroughs in the ICT, or information and communication technology. So a simultaneous increase in ICT usage to manage increase in the volume of construction is what we will see. So that's kind of direct relationship. Now, I'll give you a few examples of what we have been hearing as BIM, Building Information Modeling. Have you heard of this term? BIM, Building Information Modeling, which is a direct byproduct of information technology that I talked about. So BIM, also known as virtual design and construction, is changing everything in the way we now communicate in civil engineering and construction engineering field. Now, you don't have to read all of these things. I highlighted some of the items there. Database technologies and graphics and simulation technologies. These are very high-level computing technology. Now, we are seeing applications of them in construction. We're still not seeing very sophisticated applications, but we are seeing them, and it's increasing. Okay? We are also seeing that how BIM is being used to assess the building life cycle, constructability analysis, as well as in order to provide a framework for an interactive information system. I'll give you a few examples. We start off reading from the text. Just take a look at what BIM is doing. How a building can be seen in many different ways in front of your computer just by clicking on keyboards or using the mouse. You can see different, almost like surgeons now used to scan your body before the operation, before the surgery. So that kind of technology now we are seeing in BIM. By using BIM, and the building, even before it was constructed, we can see visualization, collision detection, constructability review, and digital as-built documents that are kept for records, as well as sequencing and phasing, site logistics, and order. Visualization. You see how quickly you can detect if there is any conflict during construction. That saves time, that saves money, that saves a lot of headache. You can see how choice of materials can change the look of your facility that you're going to build. Instead of describing it by different two-dimensional drawings, you can simply use this kind of technology. Quantity survey or estimating can be automated as well. As soon as you change something in your drawing, it changes the takeoff spreadsheet. It can be linked, and this is how it can be linked as I'm showing here. You don't need to ask the estimator to reflect the changes in the design and do the estimate again, this can be automated. Site logistics, which is another headache for construction engineers, particularly when there is limited amount of space. You can design the utilization of the space using BIM technology. 4D scheduling. Now, if we add one dimension to the 3D by adding the time as the fourth dimension, we progress. Okay, so this is also a very powerful tool that can be used to manage the logistics, to manage the procurement, to schedule the subcontractors and suppliers. Constructability analysis. Again, another example of how you can phase or design the phases of construction. This one is actually not a construction example. This simply shows how the energy is being utilized. As a matter of fact, I have heard that there is a program that tells at any given point in time how much energy is being utilized by the buildings in the New York City. By minute, by hours, you can tell the amount of energy being used in the facility. And this shows by color coding how the energy is being utilized. Structure analysis almost looks like a picture taken with a camera, but it's not. It's a virtual drawing in 3D that shows, again, how the rebars or reinforcing will be arranged before the concrete is poured. And this will also help you to detect any potential problems while doing this. Facility management, which is after construction, when the facility is being utilized. This can also, the management and utilization of the facility can also be automated by using this kind of technology. Now, BIM is not going to solve all our problems. Although you have seen very impressive examples of BIM, but BIM is still not going to solve our problems. And that's because construction generates a lot of data. So now, I actually was, last week, I was in New York in the ENR, Engineering News Record, Future Tech Conference. And in that conference, they did not talk about BIM. BIM is already yesterday's technology to them. They're talking about how to manage the data, huge amount of data that's being created. Are we really using the data that are being generated in the field and bringing them effectively in the office and then use them in the later project, next project? We are far behind in that advancement. And analytics, how to use information, how to analyze information to be more effective and more efficient. We are still behind on those. So you will see in the future that more and more emphasis is being placed on database technology in construction. Now, I'm giving you, we talked about, remember in the first few slides, I said that there are several kinds of technology. Information and communication technology is one. Now there is another kind of technology that came out of computing is automation or robotics. Now, in construction, use of robotics is not as, what should I say, as efficient as in the manufacturing industry. And I think you know why. Why? Any idea why manufacturing industry uses more robotics or more automation than construction? Anybody?
Because of the projects are different.
Huh?
Because of the projects are different.
Each project is different, very good. So construction facilities are unique. They are one of a kind. So it's very difficult to use robotics. It's not impossible, it's difficult. It's time consuming, it gets more expensive than manual labor. But it doesn't make the job very easy. So what is happening nowadays is we're trying to make the construction site as effective, make the construction site effective so that more precast elements can be used. Because if the precast elements are of same type and size, it's easy to use robotics and automation to produce them. Japanese, again, are far advanced than many other countries in automation and robotics, including in construction. So this is called ABCS, Accelerated Building Construction System. I think not accelerated, automated building construction system is used in the field. This was done by Obayashi Construction Company in Japan. The system that you are seeing here is actually used in this construction in China. This building, the way you're looking at it, is actually utilized that ABCS system, the semi-automated construction system. This is another one. This is also invented by Japanese, Obayashi again. This is called the big canopy system, the big canopy construction. As you can see again on the right side, that is the construction style, but it looks like a plant, construction plant. And the sketch that you can see here is how they build the buildings. So what you're seeing on the left side is a combination of using in situ as well as precast concrete. Of course, more precast concrete than in situ concrete, because if it is all in situ concrete built on cast on site, then it doesn't become automated. So automation means more and more use of precast elements. That's what you're seeing on the left. Now, besides computing and automation, there are also innovations taking place in other areas. One of them is materials. And it seems to me, by looking at what kind of new materials are coming into construction, I see more and more innovations in concrete. It seems to me that we are not done with concrete. Concrete is still evolving in many different ways. And some of the examples are lightweight concrete. We're trying to make concrete that is strong, but lighter than normal concrete. We're trying to make concrete stronger by using fibers, not just reinforcement bars, reinforcing bars, but fibers, carbon strands are thin, light, and very strong. Translucent concrete, whereby we are seeing concrete that are see-through. You can actually see through the concrete, eliminating the need of a lot of lighting in the buildings during the daytime and other uses. Instead of glass, for example, you can use concrete that are translucent. Nano-treated materials, another innovation that is, I would say, still in its infancy. We are seeing how the materials' properties can be changed at the atomic level, at the molecular level, so that it can be used more beneficially in construction. I have heard of using nano-treated bamboo. Of course, bamboo is used already in many, there are many applications of construction. Bamboo is very strong, the bending capacity is very high, and in many third world countries, bamboos are actually used for scaffolding because they can be very tall, 60, 70 feet tall, with a lot of bending capacity. Now they're trying to nano-treat bamboo so they can be used almost like steel. So natural materials that are available, like wood and bamboo, also contributes to what we have been hearing nowadays, sustainability. We want more and more sustainable construction, use of sustainable materials. So there is efforts in using natural, sustainable materials by treating them. So a lot of innovations are going in that area. You have heard of 3D printers? You heard of 3D printers, right? Now in Loughborough University in the United Kingdom, they are actually using a 3D printer to build concrete. They call it concrete printer. This is an example. This is an example from the lab, actually, real example. So you will also see a lot of effort in this area. Use of not just concrete, but use of, again, this probably can be, say, an application of computing technology, because it is, and how concrete structures can be formed or used, made by using printer-like machines. Now I'm switching gears to another kind of innovation that's taking place. Tallest buildings, tall structures, high-rise buildings. Now, if you write in the internet, Google, tallest buildings, you will see this picture come up. Okay? Now, this is copyrighted, so please don't use this from me. Take it from Google. So I would like, this is a little difficult to read in the bottom, but what is the tallest building now?
Burj Khalifa.
Khalifa, which is on the left here. Okay? I wanted to point out that the latest high-rise building, tallest building in the United States is which one?
No.
Sears Tower. Now it's Willis Tower. That was built in 1974. The year is written under the building. So Sears Tower is on the third from right. It's built in 1974. After that, there has been no tallest building or no tall building built in the United States. Everything else is elsewhere. The next one was in 1998. So there's a big gap between 1974 and 1998. And there was Petronas Tower, which is in the middle of the two tower.
Yes.
Petronas Tower. Now, what is the reason you think that the United States are not building tall buildings? And also, why there was a gap so high between 1974 and 1998. Now, of course, we are seeing a surge. What do you think that's happening?
Technology? Not so much technology for building more?
Not so much need.
Need.
Not so much need. The United States, of course, like any other developed countries, is already developed. They have already built their buildings. The demand for office buildings, tall buildings, wasn't there. But it was in those countries that were becoming rich. Kuala Lumpur, Malaysia, China, Taipei. And that's why you see them, Dubai. Right? But ironically, all of those buildings have been built by, I would say, the same company that built the Sears Tower, which is Skidmore, Merrill, SOM. They have contributions in all those buildings, even though they are building out there. Just a thought that I am giving you, that innovation depends on the demand. It doesn't happen without any reason, without any reason. We are seeing some innovative applications of technology in high-rise buildings. Okay, these are the examples. I'm going to go a little quick now. Are you going to make the presentation available to them? Maria? Are you going to make the presentation available to them? No. No? Okay, then I have to just go quickly. 2013 Innovation Award listed 5 technology in high-rise buildings. One process is this prefabricated construction process, similar to what we have seen before in the ABCS. This building is a hotel, 30 stories. It's built in 15 days. Only 15. You probably haven't heard of this. This is amazing. And it was done because of the technology. This is an application of high-strength cable for hoisting, like a lift or elevator cable, and the material that is used allowed them to double the height from 500 meter to 1 kilometer, almost 1,000 meter. This is a seismic isolation structure. Only the sketch is shown to show how two different mechanisms are isolated. And this was, of course, done in earthquake-prone area like Japan, so that very high level earthquake will not actually damage this high-rise building. So that's another area of technological innovation that's going on. This is the application of precast concrete, which is not new, but again, materials allowed them to create that kind of facade, and the elements are shown on the right. This is a very interesting example of using the technology of the suspension bridge in a building, in a high-rise building, to hold and suspend the slabs in the top story. So it's innovative in the way that technology from one type of structure is brought to another type of structure. Now, this is an example of thinking out of the box. You see, they didn't find a way, so created a way within the building highway. Okay? Now, these kind of things are also innovative. You can think in terms of infrastructure, how to manage them. Some of the examples, big infrastructure project examples from the United States. I just listed them. This is the 95, Interstate 95 in Miami. Just the volume of dollars, you can see that is going on in infrastructure reconstruction, I would say, in the United States. 106 million. The Alaskan Way, 3.114 billion. This is Chicago Environmental, the CREATE project, 3 billion. There are more. I have 10 of them. Dallas area, which is 397 million. They are mostly in infrastructure, meaning road and bridge construction. Delaware, 741, downtown tunnel, that's in Colorado actually, 2.89 billion. Eagle, 2.15, that's a mass transit project. I-4 in Orlando, Florida is 402 million. Miami Intermodal Center, 2.2 billion. That's going on for almost last 10 years. Near completion now. Southeast High-Speed Rail in corridor also. The cost is not known on this one, but it's just starting next decade. This is an example of Euston Tunnel in London. It's a prize-winning photo because of the size of the tunnel itself. And again, this kind of construction is significant just because of the size. The diameter of the boring machine, tunnel boring machine itself is an innovation. Now, I'm almost near the end. I want to leave you with some questions. Challenges in infrastructure construction is threefold. One is the machinery, as you have just seen, the tunnel machine I talked about. So one area is technology innovation is in the machinery. Okay? Not just automation, but machinery itself. Use of sensors. Another area is now becoming important, particularly in the bridge construction. There was a question asked by a bridge engineer that we build billions of dollars bridges, billions of dollars we spend, but we don't put sensors in them to find out how the bridge is performing. We buy a $30,000, $40,000 BMW, and there are hundreds of sensors in there. All you need is that kind of technology applied in civil engineering construction. And you can tell how the bridge is performing. Because we do spend a lot of money to know, to find out the performance of the infrastructure. So that's another area. The third is project delivery and financing. Nothing to do with actual product, but how do you finance? PPP, I think you have heard of it, public-private partnership, build, operate, transfer. These are still evolving because money is in short supply, particularly from the government side. So how we can become more efficient in financing projects is also an area of innovation in the area of infrastructure. Now, innovation has two dimensions, nothing else. It's not very complicated. One is risk, another is reward. Why do you innovate? Because you expect to be rewarded. And why do you not innovate? Because it's risky. It's very simple. These two equations are very simple. So you have to convince that there is enough reward for you to be able to invest in innovation, and also the risk is manageable. If these two things happen, innovation will also happen. Otherwise, it will be difficult. Now, who are the players or who are the champions in construction industry? Basically three: owner, designer, and constructor. Now, if all of them don't work together, innovation will not happen. Because risk has to be shared. If you, as a constructor, tell the owner that you have to take the risk. If you want to do something, if you want to do something new, and you want me to do it, you have to take all the risk. That's not going to happen. So that's why it is important to know how to organize construction, how to share risk, and how to share the reward as well. That's why it's very important. So, what are the challenges given that context? The challenges are conservative attitude. Construction engineers, civil engineers are more conservative than their mechanical engineer, computer engineer, electrical engineer counterparts. Why? There's a good reason. The good reason is that we need to be worried about safety of the people. Constructed facility cannot just be constructed. We need to be concerned about the safety of the people. That's why by nature we are a little conservative than other engineers. I talked about the difference between products and processes. And in construction, we should be worried about products, but we are more worried about processes. That's another problem that we have. And if you compare with the manufacturing industry, their main emphasis is in what? Uniqueness of the products. The process is hidden. As a consumer, I don't know how to build a car, right? But in construction, that's not true. The construction owner who finances the project has to know about the process also, how it is built. So there's a fundamental difference. There is a difference also if we compare with pharmaceutical industry, for example. They have to be innovative just to stay in business. Construction people don't have to be innovative to stay in business. You can still construct using the technology that's 50 years old. You can still be